Okay, so in this lecture, we're gonna learn about finite state machines. What are finite state machines? Finite state machines are normal sequential circuits whose states are defined, whose states are well defined. Okay, so all the sequential circuits you studied until now are examples of finite state machines. So, broadly speaking, finite state machines are divided into two. One is called mealy machine and one is called Murray machine. So what is this mealy machine? Mealy machine is an circuit or is a machine whose output depends on present input and present state. Okay, present input and present state. While Murray machine is a machine whose output depends only on present state. It doesn't depends on the present input. So these are the two main uh, finite state machines, Mealy machine and Murray machine. So we will write a code for both the machines, Mealy machine and Murray machine, uh, as use them as a sequence dictator. So first we can look the mealy machine. Okay. So we have designed an circuit that detects sequence 1 and 1. Okay, 1 1. It is based on mealy sequential circuit. That means its output depends on present input and present state. So we can look at this. There is an input X, there is a clock, there is a reset switch, and there is a output Z. As you use always block, you should declare Z as a register. And there are mainly four states. Okay, first state is 0 0, second state is 0 1, third state is 1 0, and the last state is 1 1. So uh, while we are applying reset, the present state will be uh, initial state will be A, and the 1 1, that is the final state, will be D. So here the Z becomes 1 when the present state is D and the X at the same time becomes 1. Okay, so you define 2-bit variables. S means present state, NS means next state. So you declare an always block which get activated at positive edge of clock or positive edge reset. Initially you apply a reset so that your initial state become equal to A, that is equal to 0 0, or in else case this next state will be assigned to the present state. So you apply or you declare another always block in which you monitor present state and input. Whenever these two variable change is always block become active, so you apply a case statement which depends on the values of present state. If the present state is A and the current input X equal to 0, okay, if X equal to 1, then the next state it must go to B. So if you apply if condition, if X equal to 1, the next state will be B, and in the next block this B will be assigned to present state. Okay, you know that we decide state or the decide sequence is 1 1, that is D. So for the output to become 1, we need to be in D, the 1 1 condition, and also the X should be 1. Okay, so you can see Z equal to 0, as you know it is in state A. So from here if the state is B and it receives a 1, then it goes to C, or else if receives 0, then it go back to A condition. Okay, even if in the it is the B condition, the output is 0. From B it goes to C if the input X is 1. If X becomes 0, it go back to A. Okay, C condition is 0, and the D condition or the decide condition we declare it as default. As you know, in this case statement you can declare 0 0 0 1 1 0, and 1 1 is declared as a default condition. So if the default condition, if the present input X is 1, then you make this Z1. So that is the desired condition we want. This is the desired condition we need to check in mealy circuit. Okay, if it is in present if it is in presence, if its present state is in D and the input is in 1, we make the output 1. Even if next one come, to recognize the overlapping, that means to recognize 1 1 1 1 1, if the input sequence is this way, you have a condition to first you can identify these two ones, you make this z equal to 1, consider x as always 1 for this condition. Okay, so first sequence is this, the second sequence begins from this first sequence overlapping, and next sequence begin from next sequence overlapping. So you can see there are 1 2 3 and 4 and 5 conditions. Okay, you have 5 conditions here. So if you receive x as 1, the next state would be again d. Why? The next one, if there is an overlapping, you need to detect that one, you never need go back to a. And if you receive a 0, then you need to go back to a and you should make the output 0. Okay, then you end the case and end the module. So now let's look at the uh, test circuit. Test circuit, you can say, we call a test bench. We declare inputs as registers and output as wire. We call that a module name. Initially clock is 1. Initially clock is 1, always 10. Clock become negative edge. Monitor output, input, output, present state and next state. So you call next present state and next state as st.s and st.end, as it is not declared here, it is declared inside this. You need to use this way of calling. Okay, initially input is 1, reset was 1, you know that reset is equal to 1, the present state becomes a, and after 5 seconds I disable reset, x continues to be 1, and after 20 x becomes 0, then x becomes 1, finish, and you dump it in a vcd file. Okay, so let's simulate it using icarus verilog. Okay, there is no error, we can see the output. So initially when reset condition was active, x, even though x was 1, the present state was 0. So even x is 1, the next state what want to, it want go to 0 1. Okay, so the next state and the next condition it becomes 0 1. The present state is 1, so it goes to 1 0. Next state it goes to 1. The present input is 1, so it goes to 1 1. Okay, see here the output becomes 1. Why? The present state is 1 1 and also the x is 1, so the output becomes 1. If the here you can see the input is 1, so the next state would be again 1 1, right? But here is 0. Why? The input becomes 0. That is the case of the mealy circuit. Mealy circuit, you need a present state as 1 1 and also the present input as 1. Okay, that's a difference here. So when you look at the waveform in the GTK wave, it looks like this. You can see clock, next state, reset, present state, input and output. Okay, 0 1 1 0, next state is correctly implemented, and you can see the input goes 1, goes 1 when the output goes 1 when the input is 1, and also the present state is 1 1. We have designed a circuit for detecting 1 1. Okay, see, in all these conditions you apply input as 1 and also the present state is 1 1, and when the present state is 1 and the input becomes 0, the output becomes 0. So this is the mealy circuit. So now let's look at the Moore circuit. Okay, there is only one difference in Moore circuit. You know that Moore circuit, the output depends on the present state, not on the present input. So the same set of command or same set of code you write for Moore circuit, but the only difference is here. See, in the case of default, you don't apply this x if x condition. Okay, you apply if it goes to d, then the output becomes 1. Okay, And if x is 1, input is 1, then the next state is D, else next state is A. So see, this z equal to A is declared before the if condition. In mealy circuit, we declared z equal to 1 inside the if condition. That is the biggest difference between mealy and more. Okay. So let's look at the test bench. Same test bench, no much difference. So let's simulate is using a carousel lock. Okay, no error. Okay, you see that present state you have 0 0 as input is 1, next state is 0 1. So next state you have 0 1, the input is 1, next state is 1 0, and again you have 1, the next state is 1 1. So see, here input becomes 1, input is 1, output is 1, present state is 1 1, next state is 1 1. Even though here input becomes 0, as we designed a Moore circuit, the output is still 1. Why? The present state is 1 1. It depends only on the present state. Whenever the present state becomes 1 1, irrespective of the input that is x, the output becomes 1 1. Okay. So you can see the both condition. If the input is 1, if the input is 0, the output remains 1. Why? The present state. It depends only on the present state. So when you take the GTK waveform, similar thing you can observe here, right? Okay, see, the output remains 1 even though, see this condition, see, even though input is 0, the output remains 1 because the present state is 1 1. Okay, that's the difference between Mealy circuit and Moore circuit. Okay, that's the end of this section. Thank you.